All right. Hello and welcome to the next episode of 3D and 30, no purchase necessary. We're going to talk about what that means today. And 3D and 30 is Velo 3D's LinkedIn Live and YouTube Live channel, in case you're new to the platform. We host this about every 2 weeks or so. We are in the trade show schedule, so we do modify the timing of this. Make sure you follow us on LinkedIn to get the latest show schedule because we do post it there. One of the things with additive manufacturing, and this is a great quote. Speaking of trade shows, we had a trade show last week, INTS, massive trade show for manufacturing. A lot of people were looking at additive manufacturing as a way to accelerate their pace of innovation. And people coming to the show had a lot of questions, obviously, and in researching how to adapt additive manufacturing to their company, people end up with more questions than answers. And sometimes, for some companies, these answers tend to come with a price tag. Conventional metal AM companies are known for charging significant fees for application-based consulting. In a lot of cases, if you want to adopt additive manufacturing, that means you have to have internal manufacturing capabilities, which is expensive infrastructure to build. At Velo 3D, we have a mission of getting rid of these barriers to adopting additive manufacturing, and these are the two that we wanted to tackle. So charging for application-based consulting, requiring on-site machines, those are two challenges that we wanted to resolve. And in today's 3D and 30 session titled No Purchase Necessary, we're going to talk about how we break down those barriers. To help us learn a little bit more about this, we brought on some help. We have with us today Zach Walton, our Director of Business Development, and another famous face, Gene Miller, Director of Technical Sales. How are you gentlemen doing today?
Awesome.
Doing great, thanks.
Great. Zach, can you give us a little bit of background about you and about your team?
Yep, absolutely. So I run our technical business development team here. I've been at Velo for about 3 years. Before that, I spent between 10 and 12 years going through all walks of manufacturing, from research and design engineering into manufacturing, implementation, supply chain management, as well as product and program management in the energy and turbo machinery world throughout Halliburton and Caterpillar.
Nice. Gene, a little bit about you and your organization.
Sure. I'm Gene Miller. I'm the Director of Technical Sales at Velo 3D. My background is mechanical engineering. I graduated from Colorado State University about 10 years ago. Been involved in a lot of manufacturing processes like casting, foundry, machining. Before I came to Velo about 6 years ago and started as a process engineer from the ground up, learned our groundbreaking processes and moved to the applications team, and now formed the technical sales team, which we're going to talk about today.
Perfect. And Zach, I think you kind of mentioned a little bit about the team, but you have a lot of qualifications or a lot of members on your team with a lot of qualifications. Could you give us some light into that? What type of people?
Yeah, so a lot of what we've done is based on the last kind of 3 or 4 years that both Gene and myself have been here at Velo 3D, is kind of the common themes of how we could help our customers, specifically ones that weren't going to bring manufacturing in-house or going to buy a machine right out the gate, where we were focusing more on the applications and just kind of driving adoption of our technology and folks really considering using it for production on their applications. So we actually started the tech sales team about 1.5 years ago with myself and Gene, and since then have really kind of spun these two groups out as basically the technical arm of our commercial and sales team. In terms of the background of the teams, the majority of the teams are staffed with all previous engineers. So almost each person on both myself and I believe Gene's team is anywhere between 10 to 12 years of actual industry background, whether it's aviation, aerospace, oil and gas, defense, as well as the last several years of their career working on the additive world before they joined Velo.
Also, I see we have some international folks joining us today. Thank you all for joining us. And just as a reminder, this is a live session. If you have any questions, don't hesitate to ask the team. There is a little bit of a delay, we found out, between when you submit the questions and when we actually see them. So please forgive us for that, but we'll happily deal and bring your questions to the panel. Gene, a little bit about your organization, anything that's kind of interesting in terms of the capabilities?
Yeah, we really wanted a diverse team, especially teams that are educated with the pitfalls and challenges of legacy powder bed fusion systems. So we brought on a lot of folks that are familiar with those other platforms. And I think it pays homage to how valuable the Velo value can become when compared to these other systems.
And I know in the rehearsal we were kind of talking about it. We were adding this up, nearly 100, well, over 100 years of experience between the two teams. Is that about right?
Yeah, it's at least.
That's
Yep.
powerful. So Zach, if you look at the two teams together, kind of the similarities side of it, what do the two groups do? How do they help customers?
Yeah, so kind of combined, again, being the technical arm for the commercial sales team, is a lot of folks want to understand the kind of business and commercial kind of business case around their parts, their applications, what they're wanting to actually leverage additive manufacturing, in this case, specifically our technology for. And sometimes there's often that barrier. We always like to consider it kind of having that extra engineer in your room that knows the background, knows the do's and don'ts of our technology. And that person, or that partial engineer, is kind of missing in these different organizations. And so really what we do is help subsidize that by having our resources be able to vet parts, demonstrate the technology, and really give a lot of our experience, both the legacy side, like Gene mentioned, as well as our experience here at Velo of what we can and can't do and what does and doesn't make sense.
Yeah, I do think it's impressive. Like we mentioned it a couple times already, the background of traditional and additive, and being able to see the connection between the two, because they're not separate. Like it's not like you make a part additively or conventionally. Like if you tend to combine the two approaches, and you need that understanding, right?
And I think another interesting part too is nobody in our teams are sequestered into a certain industry. So we do have folks from all walks of life. Again, like whether it's aviation, aerospace, oil and gas, defense, space, everybody works on those same type of applications, which at the heart of a lot of these different industries, they're facing the same manufacturing challenges. So it's just kind of double down and combine to make a really strong team overall.
Yeah, that's awesome. Now, Gene, you kind of get the hard question. How are these two teams different? How would you say that one team deals with some things and the other team deals with others?
Yeah, that's totally fair. I mean, as we go through this, we're telling everybody that we have a very similar skill set between these two teams. And admittedly, there is a lot of technical and expertise overlap between the two. But what technical sales is focused on that BD might not be as focused on is really the technical viability, the printability, the feasibility, and educating our customers directly on these aspects. Now, the technical aptitude of the business development team is totally there, but the focus of the technical sales team is on that goal in mind, to educate our customers and poise them for success while using our technology.
Nice. We're going to try something here for the audience that's joining us. If you're working on additive manufacturing today, if you're working on parts today, if you could just kind of give us a general indication of what you're doing, like what industries, you don't have to tell us what parts, or just the general thumbs up, let us know if this is kind of something that you're all working on, or if this is something that you're interested in. We'd love to hear from you.
Yep. I think one quick thing to add on to what Gene said as well is, I think it is important to note that about 1.5 years ago, me and Gene started the technical sales team together. And kind of like what Gene said, a lot of the folks on the technical business development team have either trained or were part of the original tech sales team. And a lot of that focus has now been geared towards more of the account management level. So once we've kind of qualified a customer that we can partner with, we can help drive the adoption of their technology, we go even further into that account and understand the different applications, the different groups in that account, and really just find any barriers that we can in the technology, materials available, processes that are available, anything that we can do to break down some of the barriers to just get even more adoption of our technology in that organization.
There's a real famous professor who wrote a book, and he was talking about the culture of adopting additive manufacturing specifically. Do you see a lot of that, or is it more of technical type of hurdles that you're dealing with versus the interpersonal?
I think it's a combination of both. I think they kind of go hand in hand, especially with the newer technology. And then specifically for our technology, which is kind of pushing the barriers and reducing the compromises, I think it adds another kind of level where both the things you're talking about kind of overlap.
Yeah, it's interesting. Yeah, Gene, we kind of mentioned no purchase necessary. Obviously, we're not giving away the machines for free. Can you kind of talk a little bit about that, and how do you see that, other than it just being a cool tagline?
Sure. This is something that I noticed with our customers, and probably before we started the technical sales team or the business development team, we saw it as a pain point for people to really get their feet wet and really understand the technology and what the implications are of utilizing it. And oftentimes it requires your own personal development of processes or your own consulting fees that you have to pay to a third party to tell you how to design your parts for the additive in general, let alone Velo 3D. So we really wanted to attack that problem, and that's what the technical sales team was built around, to provide that consulting resource, or that information free of charge, to really just smooth over those challenges and connect the dots to getting adoption going in the right direction without a lot of upfront investment.
Yeah, I think it was a mug. I went to one of those designed for additive. It was like free consulting, but you can see where it's pretty generic. They're trying to give you I think we had eyeglasses, and so we were going through what you would do in a generic sense. Is the consulting you're providing sort of like that, or do you look at a real part that these guys are working on, that teams are working?
Well, obviously we have to go through the whole NDA process, and everybody has to be comfortable with sharing our technology. But once we get to that point, we absolutely are as involved with the customer's problems and geometries as they want us to be. We have customers that come to us and just say, "Hey, print this," and we can. But the ones that want to optimize, the ones that really want to push the envelope, the ones that want to get the most bang for their buck, come right to the tech sales team or the business development team and say, "Hey, how can I optimize this for my application, for printing, for cost per part, everything?" We can cross all those T's and dot all those I's so that we can really optimize our success in our relationship with our customers.
So your team, and just kind of to go back and for folks who maybe missed it, your team is going to be looking specifically at the part. You're going to make sure that the part makes sense for the customer. You're going to break it down and help them figure out how to get it on a build plate and get it successfully done there. And then Zach, you're going to make sure that this part is going to make dollars for the customer. You're kind of doing a little bit of a business consulting to help them navigate all the way through to profitability on it seems like.
Yep. Yeah, that's a big part of it, as well as people definitely learn and are better educated when they're working on things that are close to them, like their own parts.
Yeah.
So once we actually have their parts, we're also able to explain other elements of our technology. From the preprint software of how it works to the quality software and the information that you get and the data that you get, and then how our solution simplifies the qualification needs of additive manufacturing. Doing that through the lens of their actual part, having it on a build plate in our preprint software or on the actual print file. It allows us to also broaden the overall kind of arching education on what that means for their business, their supply chains, and really scaling their adoption using our technology.
Yeah, and I think we kind of covered the consulting part. We looked at the parts. How are we getting around them owning a machine? And yeah, we're eliminating a requirement of them actually owning a machine. Can you talk about that?
Yeah, we realized very kind of early on that that was that kind of next barrier. Once somebody's had the technical and business case kind of justified or checkboxed, it was, well, how do I actually use the technology? What we decided early on is we did not want to be the kind of executor of the prints. We're not a contract manufacturer. We're a technology or manufacturing technology company. And so that wasn't really our strength. And so to reduce that barrier, what we did is we built out a very strategic and very aligned contract manufacturing network, which are CNC machine shops, folks that have access to a lot of the kind of subtractive manufacturing technologies that they could implement our technology, our manufacturing technology, and actually execute this type of work and lower that barrier to where there's OEMs that don't necessarily have to buy machines at all to be able to get the end parts they need, either in an as printed format or all the way to a full turnkey part using one of our CM partners.
Yeah, and I show kind of this list here. It's global. You've got United States, you've got European companies, Asian companies in here, so it's pretty spread out. Have you seen any issues with manufacturers like having access to CMs in certain regions, and like if they want to print something in Australia, for example? Are there any barriers to doing that?
I think it depends on the industry that you're serving, and sometimes it's more challenging than others, especially if you're in the space or super fast industry, I'll call it. These things can sometimes be challenging to cross international borders. But as far as accessibility of printing something that might not be in one of those challenging to export industries, I think we can connect Australia or the Asian market with some of our domestic contract manufacturers. But we can take that on a case by case basis and be the oil in the gears to help that happen.
And I think it's important to note too, almost everything that we do, especially from our team, is really trying to understand the voice of the customer and really what's needed from our technology, whether that's size of printer, materials, things like that, as well as where a contract manufacturer kind of needs to be enabled or expanded, especially as we start expanding globally.
Okay. So I'd be interested, if I were watching this, I'd definitely want to get started. So what's step one? How do engineers get in touch with you?
Yeah, so one of the most important things that we have, or the easiest ways that we have, is the contact engineering form on our website, which allows you to actually fill out quite a bit of the useful information that somebody from my team or Gene's team needs. From there, what we've done is we've established more of a regional footprint. So in each of the regions that we've established here in the United States and across the globe, there's a tech sales directing, and technical business development resource in each of those regions, so that you have a local presence, you have a local contact, and it's more kind of near to that time zone and able to be very, very reactionary to the requests or to anybody that's wanting to use the service.
So let's say, okay, I've got, I'm a marketing guy. I have marketing parts. Here's one pretty cool ramjet part we showed at trade shows. Gene, I'm going to come in. I'm going to start talking to you. What kind of questions or what things are we going to talk about in this conversation?
As far as parts and printing, the common questions that we get from customers is, how is this printable, or how would I go about making this happen? The questions we like to ask them are, why do you want to print this? And that's important, because we don't want to really put a square peg in a round hole. If something's easily machinable, it's probably best to keep it on a CNC or something like that. But if there's reasons like long lead times, or I can't manufacture this in any other means, like I have thin walls or internal channels that I can't cast or machine, these are the questions that I want to hear, or the answers to my question that I want to hear when we go to explore parts. And those are the ones that really stand out as being great additive parts and great velo parts. The ones that are impossible or difficult to manufacture, the long lead times is pretty much a no-brainer. We don't have the long, manufacturing of tooling delays, or the amount of debugging and de-risking that goes along with some of these processes, as well as scalability on the Velo Sapphire 2 is something that I think is revolutionary in the industry. That Velo is really changing the game here. You can print one file across the entire fleet. So you don't have to go back and tune your machine or change your print file to expand to a production level regime. So another question, that I would love to hear somebody say, I want to print 1 million of these, and, have it make sense.
Yeah, I think a little bit to add to that, like a little bit more high level as well, is really just like Gene's saying, trying to establish where their pain point is, as well as where they're going with that development. If it's more of a kind of one-off prototype, or a one-off part that doesn't have any kind of legs behind it and moving into like real production, then that's something we might have a lighter touch approach to, and transition to the CM network a little bit earlier, and let them kind of help work and use their advantages that they have. If it's something that's really gearing to what Gene's saying of big volumes needing to spread across multiple machines and have that consistency, or things that need to be done material wise, mechanical wise, to understand and kind of grow that application, then those are ones that we're going to start digging in a lot harder, and start building that relationship over the next several months and years to move them into production.
And are there certain geometries that someone should look at, or certain functionality that someone should look at to say, okay, well, this would make sense on additive or Velo? Is there any consistent thing that ties it all together?
So I would look more at the application than the general shape or geometry. It's sometimes harder to put a shell around that. If you look at things that exchange heat or flow fluid, that is generally a good fit for additive, and maybe even more specifically Velo Sapphire technology. And especially something that you have really critical success criteria, like you really want to minimize weight, or you really want to optimize performance, and you don't want a lot of design constraints that could compromise the performance of your final application, then that's a good part, or worth exploring with the Velo team. whether it be business development or technical sales.
Yeah, I think we've kind of talked about this a lot at, like, even at the recent trade show, Mike. A lot of those complex components are the ones that are channeling flow and transferring heat, and a little bit less on like maybe the structural side. And which is why if you come to one of our booths, you don't necessarily see a lot of structural components. You see a lot of very intricate, high critical components that are channeling, fluid and transferring heat.
So, what about size? Does the size of the part matter?
Yeah, absolutely. And it will help guide us as to what machine we want to put it on. We have several variants of Velo Sapphire available on the market today. There's the standard 315 millimeter diameter by 400 millimeter tall sapphire. And then there's the larger platform XC that's 600 millimeters in diameter by 550 millimeters tall. Both of these have a variant that extends that build volume upward to a full meter of build height. Now, judging on what part and what size will help drive us what machine we want to put that on, both as a geometric limitation standpoint, but also as a throughput standpoint. The Sapphire XC has 8 lasers. I mean, really is not only optimized for larger parts, but also higher volumes. If you're really trying to drive that cost per part down, the Sapphire XC is a more economical system.
I think you'll see, like, generally working with our teams, you're always almost going to see, if something can fit on a Sapphire, you're going to see the multiples that also fit on a XC to show kind of that movement into production as you get through your development phase.
Yeah, and I was kind of surprised. I probably shouldn't have been, but sometimes you'll print one part on a Sapphire, and it's not just 4 on a Sapphire XC. Sometimes it can be 7, just because there are parts that you just can't squeeze 2, but you've got a lot of extra build plate maybe they're not using, and now all that area gets taken up. So the scaling is not as easy as just 4. It could be any number.
Yep.
No, it's pretty impressive. And obviously we print in metal, but there are some materials that customers might want. How do you manage a material conversation, and what materials are qualified?
So that's a great conversation that we have on an as needed basis with each customer. Sometimes customers will just know what material they want and we can move ahead, but sometimes they don't know. And that's part of the consultation availability that the technical sales team or business development team can provide in pointing our customers in the right direction of a material. We would look at, what's the necessary strength of the material, what is the necessary weight, ductility, elongation, et cetera, and help the customer find a suitable material. And we have a plethora of materials available on our machines to date that's ever growing. Every day we seem to add a new one to this list, but fundamentally the Inconel 718 is our bread and butter alloy. We also have an Inconel 625 variant. And the titaniums and aluminums are, another bread and butter alloy that have been around on our machines for a few years now. Ameriprint Haynes 282, Hastelloy X, and C22 are other high nickel alloys, both for high corrosive environments and high temperature applications. Scalmalloy is like a structural aluminum used a lot in the aerospace industry, and GR Cop 42 is probably our newest and most popular alloy as of recently, used a lot for regeneratively cooled rocket chambers for the space industry. And another new opportunity is now with tool steel, M300 Mar-Aging steel, used for die-cast tooling inserts that have cooling channels built into the part to really extend the tool life, as well as increase throughput in the die-casting process.
And what happens if they know their material, but it's not on that list? What does that look like?
Yeah, so that's a good point. We'd have to look at the opportunity and see, if a customer is interested in buying a machine, that is a very easy conversation to have. We can do and will do free of charge the development on that alloy, being that it's weldable and theoretically 3D printable. But then also, if somebody wants something outside of that list, we're always looking for the next path towards development for our that list. And the more opportunities we find, and if it makes sense to do so, and it's going to open up a lot of new opportunities, then we would take it upon ourselves to do the development on that new material. So definitely we want to hear this. If you have interest in printing in these alloys, we really want to know, because it would not only, help us help you, but it would help us move forward into the right direction.
Yeah, it's important to note as well, like when we develop those alloys, right, it's not just providing mechanical data or adherence to an industry specification. It's also transferring the process to where you can create all the parts that you see on our website at trade shows in that new alloy when we develop it. And I think Gene also hit on a bigger note that we have kind of talked about a little bit throughout this conversation. A lot of what we do as well on both teams is really try to understand what the industry needs so that we can help guide the Velo technology roadmap in terms of capabilities, geometries, materials, or even size of printers, to understand some of the demand that's out there and some of the pain that the customers might be facing that we could put into our roadmap over the next quarters or next years.
Yeah, and I'd be curious for the audience, what materials is the audience seeing? What are you manufacturing in today? Any interesting alloys? Just add it into the chat. Be curious to hear from you. So Zach, one of the things that I was wondering, we kind of gone through this. What would you say to a customer who's still not sure, still on the fence?
I think the best approach is to still kind of reach out to us and kind of use the service in this consultation that we provide. There's never a part that we just kind of necessarily fully shy away, but we're very open and honest on what does or doesn't make sense. And I think, Gene, you'd probably agree, there's been times where we've been surprised at a geometry that might not immediately make sense off the bat, but the scalability side of what they're trying to do is the barrier, or a material where other areas could kind of accelerate if we had that alloy available, or can use one of the current alloys we currently have but need a little bit more data to kind of get that across the line. So I don't think there's any kind of barrier to kind of contact us, especially if you're on the fence. You might as well just kind of take the jump.
And you mentioned surprises, so I wanted to make sure we had enough time for this part of the show. I think this will be kind of fun. What are the craziest parts that you've seen come across your desk? And I want to open this up to any of the audience too. If you have crazy applications that you've seen, we'd love to hear from you as well. So Gene, you want to run first on that one?
Yeah, sure. I'll give you two. And we talked about one yesterday, and it was a fuel tank for a CubeSat that we printed out of titanium. And we were kind of in the running with another legacy system that had to print it in an unfavorable orientation. But I took this thing and I just, smoothed out some areas and put it in an orientation that required minimal supports, and made the post-processing super easy on this thing. But it had some really complex internal fuel line passages integral into the structure of the fuel tank that we were able to print without support on the interior, as well as to retain flowability through these small fuel passages. And the other one I'll mention happened more recently with a company that was doing power generation units. And the main goal was to really optimize weight and, make something printable. And we had this unique opportunity with this customer to go in and provide printability feedback, as well as utilize generative design software to create integral lattices to reduce weight, and really put this part together that was a combination of several parts in their system, and combine it into one part. And when you have that type of opportunity and that type of openness with a customer, man, can we just really kill it? And it was really one of those opportunities that was just blown out of the water.
Is this a part that we'll be able to talk about more publicly?
Don't know. TBD. I'd love to. I really would love to.
We're pushing.
Sounds exciting. Yeah.
Yeah.
No, it's always cool when we see some Slack channel parts of customer prints. They're just amazing innovations out there. So Zach, over to you. What's the craziest part you've seen?
Yeah, I'm going to answer it two ways. So one of them, I think the craziest request I've ever had was a wedding ring, which I know people have printed their own wedding rings before, but it just always was an interesting kind of request to get. But I think for me, and we've had me and you've had this kind of conversation on multiple 3D and 30s, really at IMTS last week, there was a lot of applications that I thought were pretty amazing. Not basically, when you see the profile of the sizes we can print, as well as the materials and the capabilities, whether it was kind of metal filtration material, or, I think you had talked about some of the dog food applications that folks had talked about. Anything that is, transferring media, fluid, or transferring heat, they really open up to industries that you might not think make a lot of sense. That once you start exploring it and understand the true pain or what is involved with actually making those components, and the true business case, and to both technical and financial behind them, there's a lot of industries that, outside of just our normal industries that start popping up. And I think we saw that on display last week at IMTS.
Yeah, everything from, like you mentioned, dog food to fission.
Yeah,
It's like, So fun conversation. I'll throw mine in. I think the one that I thought was the most interesting was like processing cadavers. So, if you get injured, if you have an ACL tear or something like that, a lot of times they'll use human cadavers to provide the tissue for the replacement, which means that they have a source material they don't always know the geometry of, because all humans are different, and they have a recipient of that material they don't always know the geometry of what will be replaced. So they have to prepare a fixturing and tooling in order to get the material that actually fits the recipient. And the person I was talking to said it sometimes takes 6 to 8 months to do that. And you can imagine having an ACL tear, and being sitting waiting for 6 to 8 months. It's life altering type of thing that you're doing. So yeah, just cutting down time for that type of thing would be massively valuable for them. So, but that was definitely one of the most interesting conversations. We're usually talking about other things, but medical is fun. So I do want to kind of mention one thing. If you've sort of enjoyed this session, we do have a helpful white paper. This is transitioning critical parts to metal 3D printing. It's a new white paper that has been released. We're going to provide a link to this in the bottom. This will kind of summarize a lot of what we're talking about, but keep in mind the process of this is Gene or Zach or one of their people talking to you, holding your hand the whole way, and being available to you to be a human being helping you through the whole process. So take advantage of the white paper, take advantage of the team. Fantastic resource, and again, no purchase necessary. So couldn't have said it any better than that. Any final thoughts from Gene or Zach?
I just think this is kind of a refreshing thing. If I were a customer and I, was kind of in the dark, I would love having this at my disposal. So I'm very optimistic that, this will be something that is embraced by a lot of industries in the future, and something that can really change the game for a lot of customers out there, because they might not have otherwise really thought of embracing additive. So I'm really excited about what we're doing.
All right, awesome.
And I think for me, I've used a lot of the kind of contact engineering throughout different, whether it was a surface treatment or something I needed when I was at Halliburton and Caterpillar. And usually on that other end of the line, it's kind of hit or miss what you're going to get. And then if you do get somebody, it's kind of multiple meetings to try to find the right person that can answer your questions. I think what we're doing is fairly unique, especially with the teams that we've built. And it's really kind of a double down of what, you constantly hear from the folks that we work with, where the support that, Velo3D gives, outside of these teams, but all of our teams, this is just an extension of the type of support we always want to be giving our customers. Now at the front end of kind of helping them with their engineering manufacturing challenges.
All right. Well, thank you both. Great session today. Thank you, audience, for joining us. Check the chat here. Oh, there is a question. Do we also provide support to customers regarding the dynamic compliance of the 3D components you print?
That's a great question, and I will try to answer it as helpfully and as fairly as I can. Now, Velo3D and the technical sales team, business development as well, will help with your manufacturing of your designs. Ownership of the design and how it behaves is gonna take a lot of give and take. Technical sales and BD can help you get there if there is a non-compliance in the printing process, or there's some sort of abnormality, say we're out of dimensional tolerance or something like that. We can help you solve those problems. But then if there's something like the overall design, if it's printed or manufactured to spec and is not behaving as expected, we'll do what we can to help, but it might be out of our wheelhouse, depending on the application of what it is. It's something that we could offer help where we could, but we're not going to take ownership of your own designs or how they actually work in your own application.
Yeah, I think even a little bit more kind of high level to that, like a lot of understanding and having the education on our technology, whether it's the preprint software, the quality software, and the information that's being provided. And basically, to your point, Gene, the tools that we would use to kind of get better understanding of what we could do, to make the part better or find any anomalies, educating those, what those parts of the technology do. That's a big thing of what both our teams do, so that you can answer, this question that you're asking, that you feel confident answering that, and you have the data and information to do so.
Mm-hmm. I've talked to customers before that really, didn't feel like they were just getting printability advice. They were also getting some good insight as to, how this part could behave, or,
Mhm.
we're all technical people and we can offer technical advice, but, ultimately the ownership of the design lays in the customer's hands, and we are there to help in any way possible.
Absolutely. Yep.
Awesome. Well, thanks again. Great question, Luis, there. Thank you for that. And audience, join us again on our next session. Stay tuned and make sure you follow us on LinkedIn to find out the latest show schedule.